Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 3 of the second lesson on non-constant acceleration. We've just got to finish off part F. So part F is asking us for the distance travelled by the particle in the third second of its motion. So we've got to think, what does that mean by the third second? Well, the first second would be from 0 to 1. The second second would be from 1 to 2. So the third second is going to be from 2 to 3. So we're looking at how far it travels between the time when t is 2 and when t is 3. So we have our expression for position, for displacement. So we're going to substitute t equals 2 in first. So x equals 3 lots of 2 squared minus a third, so 2 cubed plus 5. So it's 12, take away 8 over 3 plus 5. Which is 43 over 3. I'll just check that. 43 over 3, yeah. And then if we sub in t equals 3 to the same expression for displacement, so 3 lots of 3 squared minus a third of 3 cubed plus 5, we get 27 minus 9 plus 5, which is 23. So, what does that mean? What that means is, after 2 seconds, it's 43 over 3 metres from O. And after 3 seconds, it's 23 metres from O. So in the third second of motion, it must have travelled distance of 23 minus 43 over 3, because it's gone from 43 over 3 to 23, and that distance is 26 over 3 metres, and that is the distance that it's travelled in that time. Now just a little bit of extras here that will help out with EG3. If you think about how I got this expression for displacement, I integrated velocity. So I'm just going to go back to that velocity graph again that I drew earlier, which went from 0 to 6 on the time axis, and this was the velocity axis. What I've done is I've integrated, I've subbed in 2, I've subbed in 3. Well, what's that like? Well, what that's like is if t is 2, t is 3, what I've actually done is I've found the area between the curve and the x-axis, and that there is 26 over 3, which should make sense because when we've done speed time graphs, velocity time graphs, the way to find the distance travelled is to find the area under the curve, or the area under the line, the area between the graph and the x-axis, or in this case the time axis. But if we'd integrated this 6t minus t squared, I'll write that formally here, if we had integrated 6t minus t squared with respect to t between 3 and 2, we would get the answer 26 over 3. And it's important you understand that for what we're going to look at in example 3.